Right, gents, here we're just going to look at using the differentiating trig functions using the quotient and the product rule. So we're just going to start off by differentiating cos x sine 4x. So just a reminder, the product rule is functions of the sort of a function of x multiplied by a function of x. So here we let u equal cos x and v is equal to sine 4x. So if we differentiate these, u dash, cos differentiates to minus sine, so end up with negative sine x. V dash sine 4x differentiates to 4 cos 4x. Now, using the product rule, again, remember the product rule is that dy on dx equals u dash v plus v dash u. So therefore, we can say that dy on dx is equal to u dash v, so sine x times by negative sine x times by sine 4x, so end up with negative sine x sine 4x. Now we can't write that as sine squared because the values of x in each of these two terms are different. In the first sine we've got a single x, and in the next one we've got 4x, so we can't square those. So that's u dash v, and then we add on v dash u, and v dash u is cos x multiplied by 4 cos 4x, so we end up with 4 cos x cos 4x. And again, we can't write that as cos squared because it's this term here has a single x, this term here has 4x, so we have to leave that in the form we've got there. So that will be our derivative. Next, we're going to look at this, how to differentiate sine 2x tan 3x. So again, we're going to be using the product rule. U is equal to sine of 2x, v is equal to tan of 3x. U dash, differentiating sine 2x becomes 2 cos 2x. Now, tan 3x, tan differentiates to sec squared, and we have to multiply through by the derivative of this as well, which is 3x, so we end up with 3 sec squared 3x. And then using the product rule, we end up with dy on dx equals u dash v, so that would be 2 cos 2x tan 3x plus u v dash, which would be 3 sine 2x sec squared 3x. Will be our final answer for our first derivative there. Now, next one, we'll asked to differentiate e to the power of x sine 2x. Now, we're kind of combining two areas together here of differentiating an exponential, but also then within that using the product rule. So just a reminder, if you've got y equals e to the power of some function of x, then the derivative of this would be f dash of x e to the power of f of x. So when we're differentiating e to the x sine of x, we need to differentiate this power. Now, you'll notice that is actually a product of two functions of x and sine 2x. So in order to do that, we actually need to use the product rule. So we're going to let u equal x, so therefore u dash equals 1. We'll let v equals sine 2x, therefore v dash equals 2 cos 2x. And so if f of x is equal to that, so if f of x equals x sine 2x, then f dash of x is equal to the product rule of that. So u dash times v, so 1 times sine 2x, which is just sine 2x, times by uv dash, which would be plus 2x cos 2x. So therefore, given what we said up here at the top, that if y equals e to the f of x, then y dash equals f dash of x e to the f of x. Well, in this case then, given that y is equal to e to the x sine 2x, then y dash is equal to f dash of x, which is what we worked out just before. And I'm going to write that in brackets because there is more than one term, so sine 2x plus 2x cos 2x multiplied by the original function, which is e x sine 2x, like so. Now the last example we're going to look at here is find the derivative of, and we'll just write this in a more familiar form so it makes it a little bit easier to view, which is 3x plus 4 over sine of 5x. Now, this is a quotient rule question because it's in the form of u over v. And just a quick reminder of the quotient rule, that dy on dx is equal to u dash v minus v dash u on v squared. So again, identifying these as as u equals 3x plus 4, therefore u dash equals 3, v equals sine 5x, v dash equals 5 cos 5x, and v squared, which we need as well, will be sine squared 5x. So therefore, using the product rule, dy on dx is equal to u dash v, so 3 multiplied by sine 5x, which is 3 sine 5x, minus v dash u. Now I'm going to put the 3x plus 4 in brackets. Notice also it's 3x plus 4 multiplied by 5 cos 5x. Now we can write this multiplication in any order, so I'm going to put the 5 out the front, and then 3x plus 4 cos 5x, following it all over v squared, which is sine squared 5x. And I'm going to leave that there. We could expand this bracket out here. That's not really going to be of any serious advantage for us, so we can leave that in that form there. Alright, and that's using the product rule and the quotient rule to differentiate some trigonometric functions.